We start with a single frame taken straight from Google Street View, a crisp, high-resolution snapshot of a bustling downtown avenue, complete with traffic, storefronts, and the subtle play of light and shadow. In the blink of an eye, we swap that real-world image for something entirely new, setting the stage for what comes next. What appears next is not another photograph but a street freshly dreamed up by Google's Genie World model. In under 2 seconds, the model renders a fully navigable, photorealistic block that mirrors the original's geometry, textures, and atmospheric details, all generated from a single input image. Now picture this capability scaled up, an AI that can conjure entire neighborhoods, cities, or fantasy metropolises on demand, letting designers, gamers, and planners explore limitless worlds without ever leaving their desk. What if AI could build any city you imagine? Imagine a model that doesn't just recognize images but understands how a scene behaves over time, like a physics engine for visuals. Genie is a world model. It learns the underlying rules that govern streets, buildings, and light, so it can generate new, coherent views that obey those rules. Unlike diffusion models that iteratively denoise noise or GANs that compete to fake images, Genie predicts the next view directly from context using an autoregressive transformer. Think of it as a video game engine that renders the next frame based on what it has already seen, rather than guessing from scratch. Genie's knowledge comes from ingesting petapixels of Google Street View, millions of panoramic, geotagged images covering cities worldwide. This massive, diverse dataset teaches the model everything from typical street layouts to how sunlight shifts across facades, much like a driver learns road patterns after millions of miles. The result is a controllable, interactive world generator. You can prompt Genie with a sketch, a text description, or an existing view, and it will synthesize a new, navigable street that respects geometry, lighting, and even plausible traffic patterns, opening doors for gaming, simulation, and urban planning. We begin by pulling a raw equirectangular frame from Google Street View, applying basic pre-processing, cropping to the forward-facing hemisphere, normalizing pixel values, and tagging the camera pose, latitude, longitude, heading, pitch. This cleaned input becomes the foundation for everything that follows, ensuring the model sees a consistent, well-formatted view of the real world. Next, a vision transformer encoder processes the panorama, converting pixels into a compact latent representation. By attending across spatial and directional dimensions, the encoder captures not just appearance but also the underlying geometry, edges, vanishing points, and surface normals, packed into a 1D token sequence ready for autoregressive generation. With the latent code in hand, an autoregressive transformer samples new viewpoints step by step, predicting the next frame's tokens conditioned on the current pose delta. A lightweight diffusion decoder then turns these tokens into photorealistic RGB patches, stitching them together to form a full equirectangular image of the requested street angle. Finally, consistency checks enforce geometric validity. Predicted depth maps are compared against epipolar constraints, and a differentiable renderer validates that projected points align across frames. Any drift is corrected via a fast optimization loop. The result is a seamless, navigable street, shown live as we steer through the generated scene in real time. By feeding Genie-generated streets into autonomous driving simulators, engineers can expose self-driving stacks to millions of rare or dangerous scenarios, icy intersections, sudden pedestrians, complex construction zones, without leaving the lab. The model lets them control lighting, weather, traffic density, and vehicle mix, creating a safe, repeatable testbed that cuts real-world mileage and accelerates validation. Game developers can prompt Genie with a simple sketch or textual description and instantly receive a fully navigable, photorealistic city block that matches the requested style, cyberpunk, historic, or futuristic. Because the output respects geometry and physics, players can drive, walk, or fly through the environment without noticing seams, and the same prompt can be regenerated with variations for endless replayability. Urban planners use Genie to visualize proposed developments before any ground is broken. By inserting new buildings, adjusting street widths, or simulating tree canopies into a generated street, they can study sunlight patterns, sightlines, and pedestrian flow in an immersive walkthrough that stakeholders can explore, making decisions faster and with greater community buy-in. While Genie opens creative doors, it also raises ethical questions. Training on millions of Street View images can inadvertently memorize faces, license plates, or private details, risking privacy leaks if not properly filtered. Moreover, the ability to forge convincing street footage could be misused for disinformation or surveillance, prompting calls for transparent data governance, usage audits, and clear legal boundaries. Imagine Genie at 8K resolution, rendering every brick, leaf, and billboard in instant detail. Future upgrades will push pixel density beyond human eyesight limits, while dynamic objects, cars, cyclists, pedestrians, move fluidly, obeying physics and traffic rules. The model will learn from live sensor streams, letting it adapt to construction zones or unexpected weather in real time, turning static maps into living streets. Beyond visual cues, Genie will ingest multimodal inputs, audio from street noise, text annotations, even odometry data, creating a richer, more immersive simulation. Speech-driven prompts could summon a rainy downtown or a bustling market, while haptic feedback devices let users feel road texture. This multimodal fusion will blur the line between virtual and physical exploration. These advances will reshape industries. Autonomous fleets will train on endless, photorealistic scenarios, game studios will generate limitless worlds with a single sentence, architects will walk clients through future neighborhoods before a single foundation is laid. The ripple effect touches education, tourism, and emergency planning, turning imagination into testable reality. Now it's your turn to shape the next chapter. Drop your wildest Genie use case in the comments, whether it's a Mars colony street or a historic Renaissance boulevard. If you enjoyed this glimpse into AI's future, smash the like button, subscribe, and ring the bell so you never miss another breakthrough.